moving forward, you will find out that now you need to put the magnitude here. Oh, yeah, something. Oh yeah, thank you so much, Purity. I think I missed to multiply here. Oh God, it's supposed to have been multiplied times 3 becomes minus 12. So I think it's good that you have responded to that. So, and of course this one as well, I have never multiplied with 12. So this becomes 3 times 4 becomes minus 12, and 3 times 6 becomes 18. So this also changes, and this changes. So we get minus 13 and 18. So I hope that is now corrected. Thank you so much, Elizabeth, Brian, and Yepchuba. So this now means that when we do the magnitude, we will do something like this. This is going to be equals to 28 squared plus 13 squared. Oh, stop doing what you are doing, whoever is doing that. It's me who has the screen. Plus 18 squared, then you square root. Okay. So remove whatever you added, whoever added it. So this is supposed to give us, of course, this becomes root of 1277. And when you find that, you'll get 35.74. That is the magnitude of 3a minus b. So what I've just tried to do is to illustrate the concepts that we might have got: the subtraction, the multiplication with a scalar, and getting the magnitude. Now, the last question is asking the unit vector along a plus 32b. So so the question is asking, find the unit vector along a plus 2b. Always remember to put the arrows, and you can say this is equal to c as a vector. And therefore, you want to find c without an arrow and ac. So what the question is asking for us to get the ac. So first thing we do the addition, which is a is equals to 10. You can actually write them as points. Really doesn't matter so much. So you can actually write them in the form of 10 minus 4 and 6 plus 2 times b, which is 4, 2, 0. This gives you 10 plus 8 becomes 18, minus 4 plus 4 becomes 0, and minus and 6. I hope that is correct. Did I miss something? Indeed. What did I miss? Supposed to be 18. Is it me who missed, or is it the text that missed? Ah, yeah. I think I'm getting my notes wrong. This is 2 plus 1. So B is actually 2 plus 1. So I think I copied the wrong thing. So sorry for that. So this is supposed to be 2, 1. This is the B, and this is the A. So when you add, you get the following, which is 10 plus 4 becomes 14, minus 4 plus 2 becomes minus 2, and 6. So that is the first thing. And C can now be represented as 14ax minus 2ay plus 6az. And now we want to find the AC. AC is going to be given by C divided by C magnitude, because you normally say that this is equals to C magnitude times AC. So I hope that is clear. So we are just now saying that C itself is this one divided by the magnitude of C. So what is the magnitude of C? Magnitude of C is simply given by 14 squared plus 2 squared plus 6 squared square root. And that would give you what? This would give you 14ax minus 2ay plus 6az divided by, this gives you what? Let me see. 14 squared plus 4 plus 36 root of that is equals to 15.36. And therefore, when you want to find your AC, which is the unit vector, is simply 14 divided by that. You get something like 0.911 in direction of AX. Then you say 2 divided by this, you'd get 0.1302 AY, and plus 6 divided by this would becomes 0.3906 AZ. So this, in few words, is how we would solve that problem, and I think we have addressed it as it should be. Someone is asking, Peter is asking, why multiply all through by 3? Why do we multiply by 3? Did I multiply by 3? Peter never multiplied by 3. That is what Peter is asking. Why multiply all through by 3? All I did is this, I guess you get. This is the equation that you are given, A times 2B. So I solve that, so you get this. Then this becomes my C in terms of vector. The thing can be expressed as such. And then you divide by C modulus, you get AC, which is the unit vector in the direction of AC. And you say that this is what we got, and you solve this one. This is how we get the modulus. Each scalar in the respective coordinate, you square, and then you square root. So is that clear, Purity? I don't get your question, so probably you can rephrase, and we move on. So I have one more example here, which I wanted to do very quickly. I know time is running out. We lost some 20 minutes or so shifting from Zoom to, we are shifting from Zoom to what? We are moving from our other platform to Zoom, and I think everybody likes Zoom. It only means that it might cost some of us to use Zoom for teaching. Higher. So is there any other question or any question before we do example 1, 2? Let me know if there is any question before we move to question 1, 2. All right, we move on. And we say now that example 1, 2 says, I want to put it here so that we can see it. Now this is example 1, 2. I'm putting it here. You may say you can't see the screen, it's too small. I'm making it big. This is question 1, 2. That says that point P and Q are located at that point and that point respectively. Calculate the position of vector RP. So if you are, the first question is to calculate the position vector RP. The position of vector RP. Is it position vector? I think we should not have this. Should not have off. It should be simply calculate position vector RP. That is the correct question. So we simply say that RP is given by from point P minus point O. And this is given by 0, 2, 4. I just find it a bit better to put it in matrix form, but this is acceptable. This is 0, 0, 0, and you get as a point 0 in AX direction, plus 2 in AY direction, plus 4 in the AZ direction. This becomes the position vector RP. Isaac is asking if these examples are in the notes. Yes, they are. I just wanted to do them here so that we get to see the examples as they should. So I think I have answered your question. So that is the first question. Now, we have answered A. Part B is asking the distance from vector, the distance vector from P to Q. So it is asking for us to get R, P, and I need to confirm that the distance from P to Q. That is how you would illustrate, that is how you would write the distance vector. And what we said earlier is that it is obtained by position vector RQ minus position vector RP. And this gives you, we have seen that this is 2AY plus 4AZ. I have skipped AX because it is 0. Oh, should not have started with that one. I think I can move this one so that I start with RQ. RQ is simply obtained by adding, negating this 3AX plus AY plus 5AZ. We're saying we always minus this is RQ, position vector, and this is the position vector RP. This now, when you say RQ minus RP, it gives you the position vector for RPQ. And of course, this is simple mathematics. When you do that subtraction, you should get minus 5AX and sorry, I've just mixed up AI and AX. So all I am doing here is that I'm going to minus this one with 0. There's nothing we are mixing that with, but this is going to be minus with that, and this is going to be minus with that, because we must always take care of the unit vectors. Therefore, this is going to become minus 3AX plus AY minus 2AY becomes minus AY, and 5 minus 4 becomes AZ. Therefore, it should lead the new vector must now become minus 3AX minus AY plus AZ. AZ. Remember that we always put the hat on top of the unit vectors. So that is the distance vector RPQ. Now the distance between P and Q. Remember that when you say the distance, we are only concerned with the magnitude. So the question is asking, find the distance between P and Q. So we are only concerned with the distance, and the distance is simply a scalar. Remember that we can say we have seen that the distance. What we have found here is the distance. This is equals to the distance times the APQ times the unit vector. So we can simply say that the distance can be found by the vector APQ divided by the unit vector. Yeah, divided by the unit vector APQ. That we get the distance. And remember that we found we can find the distance by saying, or rather, APQ is equals to A times APQ. So you see this would cancel out, because if we introduce APQ down there, that means this is a unit vector and this is a unit vector, you cancel out. And therefore you're going to be left that the distance is going to be given by this A bar, and therefore, or A modulus, and therefore we can see that this simply becomes root of 3 squared plus 1 squared plus 1 squared. This becomes root of 11. And root of 11 is simply going to be equal to 3.317. So that again, we have tried to use the things that we have learned today to evaluate the distance vector and the unit and the position vector RP. The last question is now asking a vector parallel to PQ with magnitude 10. So that is calculate a vector parallel to PQ with magnitude of 10. So how would we do that? We are saying we want to have a unit vector PQ times 10, because we are saying it is going to be a vector, has a unit direction of PQ, but it has magnitude of 10. So the question here is asking us to find the unit vector APQ. And how do you find the unit vector APQ? When we said in our notes that we said that vector A is given by the magnitude A and the unit vector A hat. So now that we are being asked to find this, we simply say that A hat is going to be given by A divided by A magnitude. And that is what we have found here. In the previous step, we found that our PQ here was 3.317, or 3.317. And therefore, we also know, okay, I'm saying this, I'm quitting this to be A. So A becomes my PQ. So what was our A? Our A was, we had found our A area, which was this, minus 3AX, minus 3AX, minus AY, plus AZ. Therefore, we need to divide by 3.317 this will give us our A hat, which would be equals to some, okay, yes, this should become something, I don't need to do the division now, but then remember that the question was now asking us, are a vector parallel to PQ with magnitude of 10. So it is simply saying that 10, this is where we are. So now that we have found our APQ and we are multiplying that by 10. So this is equivalent to 10 10 times 10 times minus 3 AX minus AY plus AZ hat divided by 3.317. And this would give us the answer as, remember we had some square root somewhere, so I think that is important, that this was plus or minus because we square rooted. Whenever we square root, we always get an answer in plus or minus. So we get an answer in plus or minus, minus 9. When you do that division, you get minus 0.05 AX minus 3.02 AY plus 3.02 AZ. So that again, in very many words, expresses the example that we have just learned. So we have tried to answer the four questions which were here, and by answering those four questions, we have tried to understand the concept of a magnitude of a vector, a unit vector, a distance vector, and a position vector. So do you have any question at that point before we finish? We're about to finish because we are now jumping to vector multiplication. And once we have done vector multiplication, we go. So Brian Morena is asking me to repeat question B or part B. Of course, part B is right here. We said this was asking for distance vector, and distance vector is whenever you find RPQ from point P to Q, you always take the last one to be the starting point. So we are going to say Q minus P, and we know R, this is the position vector. It was given by this. It was given by this, and RP was given by this. That is just pure minusing. Or the only thing you have to be concerned about is that you match the unit vectors. This doesn't have AX, and therefore you minus 0. And then AY you match with the AY. So you're saying 1 minus 2 becomes minus 1 there. And 5 minus 4 becomes 1, is it? So having said that, you get this to be your distance vector RP, RPQ, a vector. And therefore, that is how we move now to find the distance vector, and we also move to find the unit vector that we multiplied with 10 to get this illustration. So is that clear? Good people? Is that clear, Brian? Okay. I think Brian has understood. So we can definitely carry on with the remaining section, which is multiplication. Now we want to talk about vector multiplication, and now bringing my screen back so that we just go through the notes. And vector multiplication involves two concepts, a dot and a cross. We say that when two vectors A and B are multiplied, the result is either a